We're going to talk about synthetic division of polynomials. And that sounds really scary, but it's actually a very simple method to divide polynomials together. There are a couple things that you want to keep in mind. This really only works with when the divisor is a binomial. Okay, the dividend can be whatever you want, but the divisor is going to be a binomial. And it says for synthetic division, the divisor must be of the form x minus a, okay, and the coefficient of the variable must be 1. Now that doesn't mean that you can only you can only divide by x minus 3 or something like that. We just might have to manipulate things a little bit to make them work. But you're going to have to pay attention to your signs, and you might have to factor out something for it to work. But again, it only works with binomials. Some of the ideas that we were talking about in the long division method also hold true for when we're doing synthetic division, and that is you want your polynomials arranged in descending order like we do on this one. The other thing you need to look out for is any skipped terms in the dividend. We don't have that situation here, but one of the differences is that we are ignoring all of the variables. We're only worried right now about coefficients. And so the setup is a little strange, but you'll see how easy the method is. And then our answer is going to be rewritten as a polynomial. So, right now we have what we need. If you remember the last slide, we have x minus some number here. Okay, so we're going to take that 2, right? Since it's minus 2, we're going to just use 2, and you put it in this little box. Okay, I don't know why, but that's just how it's always been done. And now next to this box, we're going to write all of the coefficients that show up in our dividend. Okay, so we're going to write a 1, a 6, a -1, and a -30. Okay, we're going to leave a little bit of space right here, and we're going to draw this line underneath. And now the process starts, and it's a very simple process. You take the first number and you bring it straight down. So we got a 1. Now you take the number that's in the box and multiply it by this number, and so that's 2. Now we add, so we do 6 plus 2 and get 8. And now we multiply 2 times 8 for 16. And now we keep repeating that until we're over. So we add for 15 and multiply for 30 and add and get 0. Okay, so this is telling you a couple different things here. Right now our remainder is 0. Okay, so the last number is always your remainder. Okay, and that's going to have implications later on, but right now we just know it goes in evenly because of the remainder being 0. Originally what we're looking for is what is the polynomial produced when we divide this polynomial by that one. Okay, we have 1, 8, 15, and so now we're going to write it in polynomial form. And what you're going to do is take the first coefficient and write it with 1 less degree. Okay, so this is going to be 1x squared, right? 1 less than 3. And now we're going to say plus 8x plus 15. Okay, so just remember when you're rewriting it, you start with 1 less degree than you did in your dividend. Alright, for our next example, there are a couple things that you need to look out for. And first is check if it's in descending order. It is. Okay, but you notice that we skip a term in here. There's no term that has just an x. So we're going to have to keep a place value. We're going to put a 0 in for that coefficient. The other thing to look out for is that we're not subtracting anymore. And the rule with the synthetic division is that you have to subtract here. But what we're going to do is just rewrite this as x minus a -3. Okay, and so now we have the situation that the rule calls for, and we're going to end up dividing by negative 3, and that's what goes in this little box right here. Okay, now I'm going to take all the coefficients and make sure you look out for skipped ones. So we have a 2, we have a 7, we have a 0, and a negative 5. Okay, now the process is extremely simple. Bring down the first term. We got a 2. Now we multiply these two for negative 6. Now we add for 1. Now we multiply for negative 3. Now we add for negative 3. Now we multiply for 9. And finally we add for 4. Okay, and again, we're going to start off, our first term is going to be 2x squared because that's one less than the biggest exponent in our dividend. So we're going to get 2x squared plus x minus 3. This value is your remainder, so it's going to be plus 4 over, and you still put it over the original divisor, so over x plus 3. Okay, we have another problem where we are not set up in descending order, so I'm just going to rewrite this first in descending order. So our first polynomial is really 3x cubed plus 10x squared minus 13x minus 20. And we're going to change the divisor into descending order also, so x plus 4. Okay, now remember, when you're doing synthetic division, you need to have x minus some number. So then we're going to have to rewrite this as x minus a negative 4. Okay, so that way we'll use the correct numbers when we set up. Okay, so it's really a negative 4 in the box. We're going to take the coefficients, 3, 10, negative 13, and negative 20, and start the process. Okay, and once you get used to it, it'll be very quick. So always make sure you set it up correctly. If you forget about a skipped term or you don't put it in descending order, then you'll get the complete wrong answer. So just be very careful. Okay, so we bring down the first one for a 3. Now we multiply negative 4 and 3 for negative 12. Now we add for negative 2. Now we multiply negative 4 times negative 2 for 8. Now we add for negative 5. Now we multiply for positive 20. And we have no remainder on this one as well. Okay, now we're taking one less exponent than the biggest one of the dividend. And so we're going to get 3x squared minus 2x minus 5. Alright, so as long as you're dividing by a binomial, synthetic division works. But remember of how the divisor needs to be set up. You have to have a coefficient of 1 and you have to be subtracting. But like I said before, we'll just have to manipulate this a little bit to be able to get the right answer. So the first thing I'm going to do is rewrite this as a fraction. So we're going to have 8x cubed plus 36x squared plus 46x plus 15. We're going to put that over the 2x plus 5. Okay? And again, what we're trying to have happen here is we got to manipulate this expression in some way so that we have a 1 down here instead of a 2. So what we're really going to do is factor out a 2 out of just the denominator. And we're going to leave the numerator alone. And we're going to write that, you know, it's like we're taking a 1 out of the numerator and taking a 2 out of the denominator. And so now we have a new looking expression, 8x cubed plus 36x squared plus 46x plus 15, right? We didn't take anything out of that. But then in the denominator we have 1x plus 5 halves. Alright, so now we're just going to do synthetic division with this part. And then once we get our answer, since this is an expression, this is important. Okay? So whatever we get as our answer, we're going to have to end up multiplying it by 1/2. Now, on the next slide, I'm going to set this up. And remember, we need this really to read x minus a negative 5 halves. Okay, so I just rewrote everything from the previous slide, right? We're dividing by negative 5 halves. The coefficients from our dividend was 8, 36, 46, and 15. Now, nothing is different. Okay, you just got to be able to work with fractions a little bit. So we bring down the first term for an 8, and now we multiply 8 by negative 5 halves, and that would be negative 20. Now we add and get 16 and multiply by negative 5 halves, and that would be negative 40. Now we add and have 6. 6 times negative 5 halves is negative 15, and we have a 0 as our remainder. Okay, and now what you have to do is remember that we have this 1/2 that we took out of our original problem, and so we're going to have to multiply 1/2 by our resulting polynomial, and so our answer is going to be 4x squared plus 8x plus 3.